our machining team who cover additive and subtractive manufacturing. But we'll do everything else from automation, robotics, visualization, connectivity, data analytics, and as well as that, we've got the metrology side of the team who do all the measurement across the centres. We look at non-destructive testing and evaluation, so get a really broad spectrum of capabilities. We've got quite a strong team now with individuals from various backgrounds, whether it's more academic or more industrial, and we're in a pretty good position now, having been privileged enough to grow that over the last few years, and having pretty much starting from a blank page of where do we start with digital manufacturing, how do we grow this, how do we build capability. Myself not really being from a digital background, I kind of understand that starting point of where do we go, and just over the last 4 years immersed myself in that environment, those networks, built up new connections and understanding of what the landscape was, and started to recruit and define roles and bring skills and capabilities into the centre. So it's been a really interesting journey from my point of view over the last few years. It's been really rewarding to build the team and see where the team's got to now. So really, we're here today to answer some of your questions. We've gone through this digital journey ourselves. We're still going on it. We've got a long way to go. But really, we are really open to hear other industries' point of views. If you've started in this journey and you've got some questions or some insights to share, or if you're just starting to look at digital and you've got a lot of questions, which I've had back in a few years ago as well. So it's a relaxed conversational open forum. If anyone's got any questions, you can unmute yourself and ask, or stick them in the chat and we'll get to them.
Thank you very much, Danny, Andy, and Richard, for your respective introductions there. And if I might, in the spirit of trying to foster a conversation which engages all audience members, I wonder, Laura, if I might ask you to launch the first poll that we have, which is a very simple question, which I might ask the audience to respond to, might ask you kindly to respond to, which is just simply to note the area of digital which is of most interest to yourselves or your companies this morning. We have here industrial Internet of Things, smart factories, data analytics, or other, and we would welcome your participation, please. Thank you very much. So a very good spread there. Approximately 25% of the audience. Ooh, the figures are changing here, but with approximately 80% of the audience having voted. We have a clear split of focus on data analytics and smart factory, with approximately 38% of the vote each, following after with industrial Internet of Things, which I think is good for the panel's purpose this morning, because we have received questions which speak to these areas already. So perhaps I might present one of these questions, and the first of which we'd received is, what is a smart factory and what benefits does it give to a business and a customer? And accordingly, Danny, I wonder whether you might like to field that question.
Yep, no problem. I can make a start. So
Thank you.
Smart factory is a very broad term. It will mean many things to many different people. To me, ultimately, Industry 4.0 or digital manufacturing and smart factories, they're all a kind of generalization of a group of technologies. And the real crux of these technologies is all around data. So the industrial revolutions we've gone through, power and mechanization and computerization, and when we look at the world today, the companies, when you look at the biggest companies in the world, it used to be companies that actually made things. General Electrics and the actual producers of the world. Over the last decade, or just more than the last decade, there's been a rapid change where the biggest companies in the world have become more platform based. So it's companies like Amazon and Facebook and Google, and basically the biggest part of these companies is trading in data. So you probably heard a lot of the sayings that data is the new oil and whatever else. But it's pretty much the case where we've got to now where we can start to use the computing power to analyze data more efficiently and unlock value in a way that we just haven't done previously. In some sectors, are further ahead and have been doing this for years. The financial sectors is well known to use a huge amount of data analytics and AI algorithms to understand where and how to invest huge amounts of money. Manufacturing is not where those sectors are, but manufacturing is an incredibly data-rich environment. There's inherent data in almost every piece of equipment that we use, but getting to that data isn't easy because we haven't set them up to have that data accessible. The data is part of the control system. It's part of safety systems and how computer-controlled equipment runs. But we've seen and we've demonstrated through other projects that getting access to that data and understanding how we can analyze it better, or just having the insight that that data provides means that we can start to attribute certain events or occurrences that we would just put down to your special cause variation. If you're doing a capability study, that special cause variation, we're not quite sure what that is. We're just looking for our general capability. We can start to look at that in a bigger picture type of context. If you've got enough data and you've got better means of how to analyze that through maybe some more advanced data analytics, then we can still draw insight from that. We can extract value, we can improve our processes quicker, we can take away a lot of the tedious tasks that are quite repetitive. From my experience in industry, looking at even the new product introduction, a lot of it was still kind of copy and paste, maybe 60-70% from a previous similar part. To me, if information exists electronically, it shouldn't need to be duplicated. You shouldn't have to take that from one system and put it into another one manually. That should be able to be automated. And it's those types of things that if we can free up people's time who's doing this manually and being the interface between systems and trying to extract value from data, then we can free that person up to do more creative things, because ultimately it's the creative parts that computers aren't exactly great at. So to me, smart factories, Industry 4, digital manufacturing is really just about driving better productivity within the systems that we have through using data better. So data is really absolutely key to it. Getting access to the data, how we can store and use that data, and as close to as real time as possible. Again, going back to my experience in industry, you'd be analysing data from the previous day. So by the time you've found a potential issue and you go out to the production line, those parts are long gone, and they've switched over to another job, and you've missed the opportunity to make that improvement. So it's about trying to do it as close to the event occurring as possible, and humans can't do that themselves. We will start to struggle if we've got more than 7 variables to try and juggle in our head, and we definitely cannot even read at the latency at which computers can read. So there's definitely huge amounts of benefit that we can get from these types of environments. But just to touch on another issue, it's pushing engineers into the computing science and the IT space. And your operational technology is not set up the same way as IT systems are. So if you're running a CNC machine, you really don't want the PC that's running that to crash or lag, because if you hit the emergency stop, it has to stop instantly. So knowing that we all use IT day to day, and in a Teams call, hopefully it doesn't happen today, but it can freeze, it can hang up. There's little bugs in personal computing equipment that just is unacceptable in operational equipment, so that there is still a bit of a journey to go on to get the interoperability that we see in IT systems into our operational technology on the shop floor. So that was a kind of long-winded answer, but that to me is the crux of a smart factory's data.
A very, very good answer, and thank you very much, Danny, for expanding in such detail. And I think that you'd actually brushed upon two further questions that we had here, one of which was, what are the challenges to deploying digital technologies for organizations looking at digital transformation? And specifically, in respect of data, what would be the importance of data to a manufacturer in the digital age in the context of digital transformation? And again,
so that's kind of two questions. So I'm going to split that up and completely slopey shoulder it onto Richard and Andy. So Richard, obviously leading the connectivity theme for Industrial Internet of Things, has got much more experience in terms of what the challenges are when it comes to actually getting data out of your machines. So I'll let Richard answer some of the challenges first.
Thanks. I guess from my experience, it's kind of trying to understand what you currently have existing, assets you have existing, and how modern they are to whether it's sort of open protocol based or closed. You know, it's a closed system that's been in your facility for 10, 15, 20 years. And then just leader on that is trying to understand what the best way of obtaining that data is. You know, so when we look at different types of communication protocols, they are not all easy to work with. Some are quite complicated, and it takes time to learn and understand what it is they're doing. You also want to try and understand what the best solution is for yourself as an organization. So there is no right or wrong answer when you look at these. It depends on what existing assets you have. And like I said, if you've got a closed system that you want to, build upon within a legacy asset, you really have to build a good partnership, a good relationship with the OEM of that system to really help and explore how you can open up those data channels to actually pull the data from it. And then the next challenge is, after you've got that data, is how do you organize it in such a way that you can create information or context? How do you contextualize data sets to create information so that it's of benefit to you as a manufacturing organization or an organization in general? And that's where the process experts come in. They really need to sit and work with the analytics teams and the connectivity teams to say, well, what does this data actually mean when we cross-reference it with something else? And that's why you need those process experts. So there's certainly different challenges in there and how you build that up. So I think from that perspective, yeah, it's very agnostic to the organization that you are and what it is that you do.
Thank you, Richard.
Yep. The other part of that question was around the value data can provide. So I kind of touched on that very superficially. So Andy, I don't know if you can give a bit more insight.
Yeah, sure. I think the first thing I'd like to say is about the ownership of data in the first place is that manufacturers are often unaware that a lot of the data in their environment does belong to them. Or in some cases that they may have unintentionally assigned ownership of that data to other parties. That could be the equipment within the manufacturing environment. So it's incredibly important for manufacturers to begin to understand what is the sort of the process that they have and who actually owns that before they can still start off. Because you might say, well, I've got all this data on my machine. You may not actually have the ability to access that. Could be warranties, could be that the PLC manufacturer says, no, that's all data. And in some cases, that's fine. You can work with those companies to access that data and get it off in the right format. And you might be able to negate a whole lot of trouble trying to retrofit solutions on. So I'd say that's the first thing, is to understand that a lot of this data in your manufacturing is yours, and you should be able to make use of that. The other part I'd like to talk about is that all data really is driving is decision making, and data analytics has been going on for absolute decades in manufacturing environments. People have done it for a long time, and a lot of what we're trying to do is automate these processes and build decisions on data sources that may not have had much attention paid to them It could be because there's a lot of one-offs in the manufacturing environment, which means that when you look at it individually, you may not be able to glean many insights from it. But if you're able to use different analysis techniques, you may start to get insights, even smaller confidence levels in certain manufacturing processes. You can begin to assess more comprehensively what your manufacturing environment is capable of. A lot of the time when a process is commissioned, it'll be for a particular set of components or tools. And you may find that machine is actually capable of a lot more, only if you're able to have a look at the data and be able to understand what is the true potential of that machine. Most of this data we're trying to do is to drive business decisions, ultimately operation decisions. Should I have a regular maintenance of this machine? The parts I made, are they all going to pass quality inspection further down the line as well? And a lot of what you're trying to do is reduce a lot of this manual intervention that's constantly going on to the manufacturing end for really good reasons. This is needed for safety, for quality, to ensure things are on time. And the idea is you're trying to automate a lot of this decision-making processes throughout the factory environment. This could be for the operator level, the person physically operating that machine, giving them greater contextual awareness so that they can say something's gone wrong, or I think this is going to go wrong, and then giving that information before then finding out once you made the part that did go wrong. This can also be a planning stage for your at the sort of enterprise level, when you're trying to assess what is your capacity, what you could change in your manufacturing environment. And this is all driven by data. So it's all data-driven decision-making processes, basically. So so at a high level, the importance of data manufacturing is incredibly high. It's just that the way that you try to use that will vary immensely depending on your enterprise as well. In some cases, just simply knowing if the machine's on or off can just give you a good baseline of your operations as well, rather than having that logged in a paper-based format as well. You can start to get a baseline, and this goes all the way up to understanding that can your entire manufacturing facility be completely redesigned based on the data acquired, and knowing where the bottlenecks are, knowing what machines are coming on and offline, knowing what machines from predictive condition monitoring, when they're going to fail. And so you can start to schedule all your meetings in a completely different fashion as well. Yeah.
Thanks, Andy. Just a couple of points on that. So we should all be very interested in the sustainability of manufacturing and carbon reduction, and very much data is going to be one of the main drivers for how we do that going forward. It will give us the insight to tell us, where we're using carbon unnecessarily and help us reduce that footprint. Another point you touched on about, our understanding the capabilities of our equipment better and getting those insights. We had a case study from our machining team. And my background's machining, so I've been out in the shop floor and manufacturing parts. I don't know if we've got many other machinists online, but when you're machining a part, there's obviously a lot of vibration, and if something vibrates at its own natural frequency, it starts to self-destruct. It's the whole, the opera singer smashing the glass with her voice. The glass oscillates at its own frequency from the singer's voice and shatters. So that happens in manufacturing, and you hear a real screeching from the machine, and that's going to result in a non-conforming part because you get chatter and things. So that the auto response of any machinist will be to turn the feed rate down. That stops the chatter, changes the frequencies, and you get a good part. What we found from the machining team was understanding the frequency of the parts they're manufacturing, as you can actually also turn the feed rate up so that you're not sacrificing throughput productivity. So instead of running the machine slower, run the machine faster, and you get the exact same result. We would never have been able to know that without analyzing the natural frequencies of the parts and seeing that data and seeing where the spots in the chart where the frequencies kind of stop exist, and that told us where we could have our feed rates to have the same effect but still keep the machine running at a higher than what we would usually rate, as opposed to slowing things down. So there's loads of examples of this. That wasn't a full automated industry 4 type application, but it shows insight from data that we could then apply manually and get the benefit. So there's definitely a lot of insight to be gained from data.
Thank you very much all for expanding on that. Another question which we've just received is, where is the balance between a financial productivity target and research/innovation?
It's a tricky question to answer for a number of reasons. It's dependent on the business, how that business wants to invest its profits, or how much it wants to invest in its future. One thing I will say, obviously, is the UK over the last 10 years has the government has invested about 0.6% of GDP in R&D. Just over the last year or two, the government strategy has changed in that response, and it is rapidly increasing with a target of 2.4% of GDP by 2027. Now that's already increased just in the last couple of years to 1.7%. So that's going from 0.6 to 1.7% of GDP just in a couple of years, because the government realised that investing in manufacturing and manufacturing as a sector and R&D is particularly what creates the knowledge and makes our sectors, world leading. So it's definitely recognised at the government level that the R&D is really important. That's ramping up rapidly. As I say, by up to 2.4% by 2027, and the main ambition sometime beyond that is to get to 3% of GDP. So that won't really answer the question in terms of individual businesses where they should strike a balance, but that's down to each individual business to say, how much should we invest in our future, because that's ultimately what you're doing is, where are your competitors? If they invest more than you, where does the business go? So it's looking at the landscape, making those decisions. It's not an easy decision to make, but ultimately there's plenty of anecdotes of being first and early adopters even. So I can't give an exact figure on that, but I would definitely say you want to be investing in your future, and R&D is definitely your future.
Thank you, Danny. Richard, I wonder whether you have anything to add?
No, not really. I think Danny covered the question pretty well. I mean, it all depends on the business strategy going forward. Obviously any investment should, have a return on investment, should add value to your business. So it really is dependent on what that strategic approach is from that organization.
Thank you very much. One other question that we've just had, and it relates again to the digital transformation. Which area of digital technologies should a company, should an organization focus, and this relates to an SME, should they focus their attention on? Is it connectivity? Is it visualization? Is it data gathering, etc.?
So again, this is a really tricky question, and it's very specific to each individual company. What I would say is it very much depends on your business. So let's, for example, if we look at a large organization like Rolls-Royce, large aerospace manufacturer, they've pretty much got every problem under the sun because they've got a huge complex product. So they really want to get the best efficiency out of that product, understand how it's performing 24/7. So they really want to apply digital technologies to their product. They've also got a huge amount of parts to manufacture, so they've got real high volume production facilities where the value isn't necessarily in the parts, the value is in keeping the assets running, their production line, because getting the throughput is more important than individual parts. So that's where you want to apply digital technology to your manufacturing process as opposed to the product that you're making. So it's very much dependent on where you sit as a business. If you're more supply chain, then it's going to be a lot about how you can schedule smarter and better, how you can keep your OEE, your overall equipment efficiency up more, and how you can improve your quality so that you're not having to do rework. Again, companies like Rolls-Royce, Agreco, where they've got a large complex asset that's going to be out operational in the field, then it's about how do you connect to that device, how many sensors do you have on it, what data do you look at, you're assessing performance to make sure, as you've probably looked at servitization or outcome-based contracts. if you're getting paid for how many hours that engine flies, you want to make sure that it's available as close to 100% of the time as possible. So it's pretty much dependent on your business model and what your product is and how you run. So again, I can't give a specific answer that fits all, but we can discuss that on a one-to-one basis and kind of look at businesses and individual instances.
I mean, being biased here and working in connectivity, my kind of thought would be focusing on data acquisition. You know, so at least you can start to work with what you understand within your shop floor or within your office or whatever manufacturing processes that you do. So you can then start to build upon those fundamentals of, you know, pulling data from systems and then starting to connect assets together, and then really trying to join the journey from start to finish, and then being able to visualize that. And then from there, as an organization, you can start to consider about, you know, if you want to take that further, if you want to explore it further through visualization or analytics methods. But it's really kind of just building upon the sort of lean manufacturing principles that have been around for years, and the total productive maintenance strategies that you've been developed by organizations in Asia, and that it's really about understanding what your process is doing and how you can make it more efficient and more productive. So then you have more competitive advantage in this global market space.
Thank you very much, Richard, and I hope that's answered the question with enough clarity. And if I might, just to expand on what Danny had said, we very much do here at the digital team welcome any kind of queries and inquiries that you may have, and we welcome one-to-one conversations. Accordingly, in a moment, I will stick up the contact details for the team for any inquiries which you may have. But finally, I suppose I'd just like to ask the audience whether there are any more questions for our panel today.
There's one in the chat, Sam.
Thank you very much, Danny.
In terms of data management, what cyber and information management standards do you expect to be implementing at NMIS? Andy, that sounds like a question for you.
Thank you both.
Yeah, so in terms of cyber, just to be clear, we're not cyber experts in terms of cybersecurity. We work with companies who are cyber experts. There's a broad range of companies out there who are able to offer solutions, and we're interested in trying to implement them very specifically for manufacturing. In terms of the standards, off the top of my head, I can't remember what they are, but I think it's ISO 27001 is the basic cyber essentials. Yeah. And there's a few other ones as well. I note in cyber is that there's a lot of vulnerabilities on PLCs, and some of the partners that we've worked with have been identifying these. And so there's issues when you start to connect up certain systems that you have to be aware of. And at MIS, we're trying to at least understand that so we can provide that information to manufacturers saying, well, look, you might have issues given your portfolio of industrial controllers and whatnot as well. So yeah, that's how we're trying to, we are conscious of the threat of bringing your OT and your operational technology environment and making that in any way almost network facing. So it's a big concern, and we are looking at developing solutions with some of our cybersecurity partners to mitigate that. In terms of data,
sorry, I was just going to add that, Andy, there is a health and safety executive operational guidance documentation out there called OG86, which basically gives guidance to manufacturers about how they need to make their assets more digitally secure on the shop floor. I think that's something we'll probably approach with as we go through the digital factory process as well, and build up that knowledge and capability, working with our cyber partners to work with organisations. It should also be said that the HVMC are looking at across the 7 centres, best practices as well for cybersecurity and manufacturing.
I think the other part was on data management, and that's a big challenge at the moment because what we've got within MIS is a huge range of manufacturing processes as well, and very different data types, primarily time series data, which is generally more straightforward than some other types. Like vision-based systems as well, but still has its own challenges in terms of the quantity of data. Some of this data is coming off like 100 hertz more, and that quickly becomes a challenge, especially if you've got 40 discrete data streams all sampling that frequency as well. So the data management standards were not implemented, I'd say, many yet, but will be under Resume once we've started to gather that data and get an understanding of what are the processes. So just to be clear, one of our test beds is resource efficient supply manufacturing environment. And that's about building up a connected manufacturing facility based on the existing assets that we have as well. And as part of that, the first stage is to understand what is the data we're pulling off, because a lot of cases we won't need to pull off that data beyond an edge device into a server. But at the start we will, just so we can get an understanding about what are the challenges associated with that, and then selecting the right standards to do that. There are standards out there, I think, can't really think off the top of my head, but there are some out there. But we found that using them and trying to implement them can be a challenge depending on the type of data sources you have within the manufacturing environment.
Thank you very much. And Bruce, we look forward to receiving your emails and arranging conversations with yourself directly. So thank you very much. Danny, as I can't see the chat question box, are there any more that have popped up in the last moment, please?
I think that's all that was in the chat that was unanswered. I think that's us.
Thank you very much. So I suppose it remains for me to thank our audience today for your participation and attendance. Naturally, we welcome any questions that you may have around any of the areas which we've discussed today, or any others as they pertain to digital or wider manufacturing for other colleagues within NMIS. I'd like to thank our panel today. Andy, Richard and Danny, thank you very much for your considered contributions and interesting ones. And I'd like to thank our marketing team for having arranged today's session. So thank you very much, Laura and Debbie. And finally, before I go, to promote next week's NMIS Insights conversation, which will be with the NMIS new SME engagement team. Which will be focusing on their constitution, interactions, and aims and objectives. So we look forward to that very much, and that is next Wednesday at the same time, I believe, as well. So just remains for me to thank everybody and wish everybody a pleasant day. We look forward to hearing from you in the future. Thank you.
Yeah, thanks everybody. Cheers.
Thanks everyone. Thanks
Good
Sam
afternoon.
for hosting us.
Cheers, Sam.
Thank you, Danny.
Good effort, Sam. Well done.
Diolch. Yeah.